Hello everyone, Namaskar, Raj Krishna this side, and let's learn bisection method today with the help of this problem. So because I had to use the calculator and to show some time saving hacks of the calculator to solve this type of problem, so that's why I'm using my phone to shoot the video. So we have to find the real root of the equation, this equation, okay. So equation will be given, we have to find root numerically. You can find this root by other algebraic methods also, but the main aim of this method, bisection method, is to find it numerically, okay, with the help of calculations. Now what is the basic idea of this? Suppose let's take a random polynomial graph which looks something like this. This might not always be the case, but let's take a random one. So this is the graph. Now if you take this portion for some time, so see, these are the two roots, okay. So we'll be able to find one root at a time only from this method. So let's suppose this is the root we'll be finding. So as you can see, in the left of this dot, before it intersected this x-axis, the value of the function was positive, okay. This is the graph of fx. So this is let's say point A, point B. So exactly f of A is 0, okay, exactly f of B is 0, but in the left of A the value of the function is positive. In the right of A, till it reaches the point B, it is negative again. So sign is changing at A. That's what we are saying, that the sign or the value of the function is changing at A and B. So this is the main funda of this method. There are multiple methods. This methods is the lengthiest of all of them. So as we move forward, the method will get simpler, but right now we have to start with bisection method. So let's focus on this. So what will be the steps? Let's focus on that. Basic 3 steps are there. So the first step will be find an interval. Find an interval which will be a comma b, okay, in which root lie, because I told you root lies. Now in this case your interval would be, let's say you have started randomly from this point, and here you get some other point. This is the first check which you will be doing. Now if I plot this linearly, so this is the case. So this is where your root lie, let's say that k. Now you have started from point A and point B. At point A the value of function is negative, at point B it is positive. Now root is lying somewhere in the middle. I don't know where it lies. If I know, then I would directly write, but I don't know where it lies. Now we have found the interval, this a comma b. Root is definitely lying in this interval, but I have to reach root from both the sides. So I will have to decrease the length of the line, okay. How will I do this? So when I get the interval, then I start shrinking the interval by this x1. This is the first iteration. This is a plus b divided by 2. When you do this, you somehow reach some point in the middle, not exactly the root. Let us not show that, but this is let's say that x1. I don't know where the root is, but you are reaching in the middle, exactly in the middle, okay. Now after you get this x1 point, you will have to check the value of function you will have some function fx equals to 0. Now check the value of function that x1. Now if this fx is greater than 0, then change, let's write this minus on top and plus on top so that you don't get confused. If you get it positive, b corresponds to positive, change b to x1. So your new interval will be a comma x1. And in case if this f of x1 is lesser than 0, then change this a corresponds to negative, then change it to x1 comma b. I'm changing this interval to x1 comma. Okay, so this is the basic two step, and you will iteration, that means we'll continue doing this step. Again go to step 1, then follow step 2. Again for the next iteration, go to step 1, follow step 2. Again go to step 1, follow step 2. As per the requirement of the problem, they will say up to how many iteration or up to how many decimal places. Okay, so in case in subsequent iteration, okay, let's say in 5th and 6th iteration, up to 2 decimal places you are getting same, then in that case you will stop. Okay, that is the approximate route we have, which you have got. Now if they ask you up to 3 decimal, then you have to check in previous step and the next step. That means in 2 subsequent steps you have to check whether 3 decimal is same or not. That will be clear with the help of this problem. So let's come to this problem. So find the real root of this. So if I say fx in this case is x³ minus 2x minus 5. Now I will have to check for values. So if I check the value at 0, it is coming out to be minus 5. If I check the value at 1, it is coming out to be 1 minus 2 minus 5. So this is coming out to be 1 minus 7, which is minus 6. If you check the value at 2, it is 8 minus 4 minus 5, 8 minus 9. So 8 minus 9 is minus 1. Check the value at 3, 27 minus 6 minus 5, 27 minus 11, 16. Now you saw at 2 the value of the function is negative, at 3 the value of the function is positive. So this shows that definitely one of the root of this equation is lying between, we don't have to find all the roots, we have to find one root. So one of the root definitely lies between 2 and 3. Fine. So you got your interval. Now it's up to you that before starting iteration you want to further shorten this interval or not, because you can do that so that you have to do lesser number of iteration. If I further shorten this interval by choosing some more values like between 2 and 3, then interval will be shortened and number of iteration will reduce. Otherwise in some cases you have to go up to dozen iteration, 12, 13, 14. That becomes irritating in some case. So you can check for values at which point it is positive, negative, it is changing from negative to positive at first. So then you can do, but for the first problem we are considering this interval only. Now I'll start with iteration. So for that I will have to draw the table, but before that let's turn on our calculator. So if I use this, what I will do, I have my function which is and I will have to do this iteration every time. Let's say that xi, this is a plus b by 2. Then I will have to always check the value of that function at xi always. And I'm not concerned about exact value, but I will have to check whether it is positive or negative, so that I get my next interval. I change my next interval accordingly. Okay, so for that I will be using calculator. So because in this question it is not mentioned up to how many decimal places, so for the sake of simplicity I'm taking up to 6 decimal places. And how we do that, we go to shift and mode, and you fix your decimal. This is for 6. You can fix anyway between 1 and 9. So if I press 6, it says fix your decimal number of decimal places between 0 and 9. So I choose, let's say 6. Okay, so when I fixed it to 6, next what I have to do, I have to make my function so that I don't have to type this, solve it again and again. Like if you don't want to solve 2.5 cube minus 2 into 2.5 minus 5 again and again, so function will do that for you. So how we do that, first we find this xi, that means your x value, that is a plus b by 2. So I'm changing function nomenclature a bit. So instead of that I am saying c. So alpha, here is a c, equals to, not this equal to, you have to use this one, alpha, and solve. So c equals to this bracket opens, and again because you have to type in a, so you have to press alpha a. Okay, then plus you can use this one also, and b, so alpha and b, which is here. Close the bracket. We have created this value of xi. For every iteration I will use this function only. And now in order to calculate this, whether its value is positive or negative, I will have to do one more thing. So alpha and this symbol, now I have to find the value of function at this c point, because this c is nothing but a plus b by 2, which I have named as xi. So I have to find the value of function at xi, that means value of function at c. So if I put c here, so it will be c cube minus 2c minus 5. Shift c cube. I come down, minus 2c minus 5. There we go. We have done our job as far as creating function is concerned, and now you press calc. So now they, although they are giving random values to you, but you have to start your putting your values, and after some time this calculator will help you, because anyway you are fixing one value, you are changing only one value. So that will help you save lot of time. Let me draw one table for you. So roughly I have drawn up to 10. Let's see we need more than that, or it will work on this. Okay, I will stop when I will get the 2 iterations same, because it is not mentioned in my problem that up to how many iteration or how many decimal place. So I'm just explaining, this is my first problem, so I will stop whenever I will get the same. Okay, so, and these values are approximate, mind that. Okay, so after wasting 14 minutes or 15 minutes of yours, let's start in. So first value of a, let's write negative here, because we are getting negative at this point and positive at this point. So the first value will come from our interval, which is 2 and 3. So this is 2, this is 3. And here comes the role of calculator. This A, for our calculator, it is capital A. This is capital B. This is C for our calculator. So if you want, you can write this. This is C, and for calculator, this is F of C. Fine. So he's asking for A. Let's give him A, which is 2. Then he's asking for B, which is 3. Then he has given me the value of A plus B. Oh, I made one mistake. A plus B by 2 I have to write. So anyway, let's make some changes. I will quickly do that for you. So shift mod up to 6 decimal places I am fixing. So first I am doing C equals to A plus B divided by 2. It should be there. And now function is x cube minus 2x minus 5. So in terms of C, it will be C cube minus 2C and minus 5. Yes. And press calc. Okay. So A value is 2. Fine. Let's move to the value of B, which is 3. Now I have calculated, you see. Now sometimes it comes fraction, so you have to press this. This comes as 2.5. And if you press equal to, this will show the value of function at 2.5. Again, this fractional. So 5.625. You don't need to bother about writing this. You can write randomly. Okay. 5.625 0 0 0. But only thing you have to make sure check is this is positive. So because it is positive, I will, my new interval, negative portion will be fixed. That means 2 will copy down because it was positive. So this will now change to 2.5. Whatever is there sign, change that. Okay. So positive, so change the positive one to this xi value. Okay. Now again, same thing repeat, 2, 2.5. Okay. So A value is 2. B value is 2.5. Although I didn't need to press 2 because it was already there. So 2, 2.5. So the value which they are giving is 9 by 4, which is 2.25. 2.25. Whatever the value of the function, equal to 120, again 1.890 roughly. I don't need the exact value. So this is positive again. I will have to change the value of B. So A remains as it is. This changes to 2.25. Okay. Now again equal to A value. Again, I don't need to press 2 because 2 is already there. Just need to change B value, which is 2.25 now. 2.25. Okay. So C they are giving as 2.125. Fine. And what about the value of function? That is 0.345. Positive again. So this 2 remains as it is. This changes to 2.125. So as you can see, root is, we are coming closer to the root now. Again, 2 and 1.25. 2 is same. 2.125. 2.125. Fine. Okay. So 2.125 and they are giving as 2.0625. 2.0625. And what about the value of function? It is positive or negative? It is negative this time, minus 0.351. Okay, so first time it came negative, so we will now change the negative one to 2.0625. so now for the first time this will change to this. This will remain as it is. Calculator knows that. So now we'll have to change the value of a to 2.0625. 2.0625. b 2.125 as it is. And this came out to be positive. What is that? 2.09. I only need the sign which is positive. And also I had to check this. So again, sorry, this is not 2.09. This is the value of c, which is 2.093750. And what about the value of function? This is again negative this time. Okay, sorry. So negative of 0.008, and this is negative, so I will have to change this one to 2.093750. Positive one remains as it is. So I will have to change this to 2.093750. Fine. B value is 2.125 as it is. C they are giving is positive 2.10. 2.10. And what about the value of function? 0. Positive. So positive, so this remains as it is. Positive changes to 2.10. Fine. Now again, a value same. This b becomes 2.10. 2.10. C is your positive. I don't need positive, I need the exact value. 2.096875. What the value of function? 0.025. This is positive. I will have to change this value now. Fine. Now again, same. 2.096875. 2.096875. C they are giving as 2.095. 313. Value of function 0.008. Positive. So 2.093750. This changes to 2.095313. Again, same value. B value is 2.095313. C value is 2.094532. And the value of the function is minus 0.000, and this is negative. Okay, so right now as you can see, none of the values have come. The values have come obviously lot closer, but not exactly equal. At least up to 2 decimal they have become closer. Let's do some more iteration. You can, if you want up to 2 decimal places, then you can report the root now up to accurate up to 2 decimal places. It is 2.09. okay, but we need some more accuracy in our results, so let's proceed with some more iteration. So because it came negative, so this changes to 2.094532, 2.095313. So A is changing to 2.94532, B is changing to 2.095313, and you're getting your C as 2. Oh, what has happened here? I need to check. It came negative, so I changed by 0.2.094532 and 2. Let's do that once again. So A is 2.094532. B value is 0.2.095313. That's what I was saying, that how it came that different. 2.094923. Now as you can see, till previous step up it was correct up to 2 decimal places. Now the accuracy has reached up to 3 decimal places, as you can see. And whatever the value of function, 0.0041, which is positive. So we have done up to 3 iteration. Are you interested in doing accurate up to 4 decimal? Then let's move to some more iteration. You can leave the video here only, because you have understood now clear how to solve. Now again positive, so this remains as it is. This I will have to change to 2.094923. A value is same, B value is 2.094923, and you are getting 2.094728. Okay, and this is the value of the function is 0.001. I don't know how much more iteration I need for one more decimal value. So this is positive, and we are in 12th iteration. This will be as it is, because this is positive, so I will have to change to 0.2.094728. A is same, and your B is 2.094728, getting a C value as 2.094630. We are coming closer. Let's see. Value of the function positive, 0.000, positive indeed, positive. So this remains as it is, 2.094532, and now this changes to 2.094630. So A remains as it is, B changes to 2.094630, and you are getting your value of C as 2.094581. Now I was thinking, let's do that once again. I feel doubt for this, because from 7 to 6, 6 to 5. Okay, fine, let's move to the next Value of function is again positive, 0.000 positive. 14th one positive, so this remains 2.094532. So if I had done some mistake, it must be in this step, I think, otherwise. So A value is same, B value is 2.094581, and they are calculating is C as 2.094557. Correct. I am now confident. 2.0945, 2.0945. Now I will leave, because let's see, value of function 0.000. So as you can see, the value of function is started reaching 0. That means you have reached way much closer to the roots, and this is positive, and you can continue if you wish, but this is, I think, they will not ask you much more than this. Okay, and as I told you, if you want to lessen the number of iteration in this place, what you have to do, you know that root is lying between 2 and 3. Now let me show you something. Now move more closer, check the value of this function at let's say 2.5. let's say what is that. Now I will type manually. So 2.5, it will be 2.5 cube, and then this 2 into 2.5 is 5, so minus 5 minus 5, so minus of 10. This is positive. So at 2.5 it is also positive. Fine. And it is negative as 2. So this clearly says that your root, you can also take this interval between 2 and 2.5, because it is negative here, positive here. Now if you want more accuracy, I will not say to be more accurate at this point only, go for this, okay, because this is meant for accuracy. But if you can do this, if you can write in exam, and the first step only is value of function at 2, if you are so accurate, value of second is 2.5. okay, you have lessened the number of iteration at this point only. This is some hack which we do. So 2 to 2.5, more accurate you want to become. So let's check at 2.3. Let's check. Although I can see the root like this, so can I go for 2.2? let's check for 2.2. so if I say 2.2, okay, power 3, and this is 2 into 2.2, that means 4.4, and minus 9.4, minus of 9.4. Again positive. Fine. So you have reached even more closer. These are just trick. Don't do this in exam this much accurate, otherwise teacher will have a close eye on your solution. Now 2 and 2.2, again, as I can see the root besides me, so let's go for 2.1. so 2.1 cube, and then I go for 2.1, 4.2 and 5, 9.2, minus of 9.2. 0.06. Fine, but still positive. So see how much you have, the difference you see 1 unit, the difference you see 0.5 unit, the difference you see zero point 0.2 unit, the difference you see 0.1 unit. So the more closer you do, the number of iteration will start decreasing. These are some hacks. So in exam you can roughly see that, okay, if I do this, if I go for this, the number of iteration will that. So directly, instead of writing for 3, after 2 check for 2.2, and obviously this will negative, this will be positive, and you can start your first iteration like this: 2 plus 2.2 divided by 2, and so on. You can do your iteration. So this was the first an introductory video on bisection method, and we'll solve more and more problems as we proceed. But this was what the use of calculator is mandatory if you want to excel this method. So that's it from my side. See you with more such videos. Thanks again.